With atoms, we actually found out something with atoms. We have isotopes. So what exactly is an isotope, Dr. J? Well, an isotope is basically atoms with the same number of protons, but different amount of neutrons. An element has a certain amount of protons. That's what makes it its element, because of those certain amount of protons. All right, so this can be written in a certain different ways. All right, so this neon 20, or you can have it neon 2010 neon. All right, either way. We're just looking at the symbol here. We got three different neons. We got neon 20, 21, and 22. What exactly is the difference between 20, 21, and 22? Let's figure that out. Once again, let's just think about this word isotope. Atoms, the same number of protons, different amount of neutrons. So if neon, in order for it to be neon, neon must have 10 protons. All right? If you don't have 10 protons, you don't have neon. Okay? So neon will always have 10 protons. Bam. So neon 20 has 10 protons. Neon 21 has 10 protons. Neon 22 has 10 protons. Okay, cool. What's the difference still? The difference is the amount of neutrons each one of these isotopes has. Neon 20 has 10 neutrons. Okay, so since it has 10 neutrons, it has a mass number of 20. So let's just talk about this right now. We're going to talk about this more in periodic table, but the mass number is protons plus neutrons. That gives you your mass number. All right. So we don't got to do any fancy math here. What we're going to do to figure out the mass number is we're going to add our protons plus our neutrons to get our mass number. So 10 plus 10 is 20. This is my mass number. Okay. Now we can see, right, this is how they have it kind of set up with the symbols, right? So let's go back here. Neon 20 is telling me that, well, the 20 is for the mass number. The 20 here, right? Or this version of my symbol, the mass number will be on the top and the proton number will be on the bottom. Okay. So I have 10 protons because that's neon, but I have a 20 here for my mass number. So neon 20, all right, is this first example here. Let's look at the second isotope. So neon 21, all right, so neon 21. We know that the number of protons is 10. And then in this case, I have 11 neutrons. So, right, I got a different amount of neutrons. This is an isotope, right? So 10 plus 11, that's 21. My mass number is going to be 21, which we can see this in a symbol form here. And then if I look at the last one here, right, neon 22, this is letting me know, once again, we still have neon here. So we have 10 protons, 12 neutrons, and if we add this together, we have a mass number of 22, right, which we see it formed here. So what we understand is, right, neon is always going to have 10 protons, right? That's not going to change. But each element has a certain amount of isotopes, all right? So in this case, neon has 3 isotopes, okay? And once again, isotopes are just the same number of protons, different amount of neutrons, okay? And we can look at this other example too, right? Sodium, right? Sodium, we can see that sodium 23 and sodium 24, right? The only difference is how many neutrons it has. Now, let's talk about natural abundance. All right, I got a whole slide dedicated to this. But with natural abundance, right, we have to think about natural abundance in as it sounds, right? Which one is naturally abundant? So natural abundance tells me which isotope exists the most in the world. That's how we could think about this, right? So neon 20 is 90% naturally abundant. So of all of the isotopes in the world, of all of neon, 90% of neon is neon 20. All right, if you ever find neon or if you're dealing with neon, it's probably going to be neon 20 because 90% of all the neon is neon 20. If you go to neon 21, right, if we look at this isotope, This is telling me that it's not as abundant as neon 20. It's only 0.27% abundant. So because of this, right, this is a very rare isotope. It's not naturally abundant. And if we look one more at neon 22, right, this is going to tell me once again that it's 9.25% naturally abundant. Okay, so we only got 9% of this neon 22 in the world. Okay, and this is how we have to think about, right, all of our elements, right, is that we have isotopes to each element. Okay, and then certain isotopes are going to exist more in the world. We're going to cover natural abundance more in detail later on, but for now, just understand that concept.